Ever heard the saying, a body at rest will stay at rest and a body in motion will stay in motion? That is one of the basic laws of motion, and it is something you probably take for granted. For example, if you put a book on a table, you expect it to be there later, unless someone moves it, right? So an object that is at rest, like this ball, will remain at rest unless something makes it move. The word we use to describe what keeps the ball from moving is inertia. The heavier an object is, the more material it is composed of, the more inertia it has. For example, it might not take much to move the ball if it were a marble. But what if it were a bowling ball? The bowling ball is heavier and has more inertia. But the law of motion also says that a body in motion will stay in motion unless something makes it stop. When an object is in motion, like this ball, we say it has momentum. And just like before, the more a moving object weighs, the greater momentum it has. What happens when an object that is in motion meets an object that is at rest? If the objects weigh about the same, like these two pool balls, the one at rest will be knocked into motion. But if the one in motion is a pool ball and the one at rest is a bowling ball, it is a different story. What takes place when one ball strikes the other is called an energy transfer. According to a scientific law called the conservation of energy, there is only so much energy in the whole universe. Energy is neither created nor destroyed. It is only transferred from one object to another, or from one form to another. When an object in motion collides with one at rest, energy is transferred from the moving object to the one that was standing still, causing it to move. We call this energy of motion. But not all the energy of motion is transferred to the second object. Some of it becomes sound or heat. The more weight and momentum an object has, the more energy of motion it will transfer to the second object. For example, a slow-moving tennis ball has less weight and momentum than a fast-moving pool ball. So when this ball is struck by the pool ball, it moves much farther than when it is struck by the tennis ball. When two or more objects crash into each other with force, it is called a collision. Here is something that can help us learn more about energy, momentum, inertia, and collisions. This is called a Newton's cradle. You may have seen one before. When ball number 1 is pulled back and released, it hits ball number 2, which does not move. Neither does ball number 3 or 4. But ball number 5 does move. So what is really going on here? To understand what Newton's cradle is showing us, it is good to know a little more about energy. All objects have energy, but objects that are moving have what we call energy of motion. Objects that are standing still have stored energy. Remember, energy cannot be created or destroyed, only transferred. When the balls of the Newton's cradle are sitting still, they all have stored energy. When ball number 1 is pulled back, it builds up more stored energy due to its position above the others. When it is released, the stored energy becomes energy of motion as it swings back into place. When it strikes ball number 2, its energy of motion is transferred into stored energy, which moves through the balls until it reaches ball number 5. Then it turns back into energy of motion, and ball number 5 swings up. The action is repeated when this ball swings back and strikes ball number 4. We call this kind of collision, where energy is transferred back and forth from energy of motion to stored energy, an elastic collision. With Newton's cradle, each time the balls strike one another, some of the energy of motion becomes sound and heat. So eventually, the balls stop moving. That is why Newton's cradle is not a true elastic collision. An inelastic collision is one where energy of motion is lost because it is transferred into a different form of energy. Most collisions we experience in real life are inelastic collisions. This car crash is an example of an inelastic collision. When the car hits the pole does not move. So where did the energy of motion go? Some of it produced the sound waves, which was the loud crash you heard. Some of the energy was absorbed by the car as its body crumpled, and some was released as heat during the collision. Notice how the car and pole are almost stuck together. That is another place where energy goes in an inelastic collision. The next time you see one object hit another, think about inertia and momentum. Can you figure out how energy was transferred? Was there an elastic or inelastic collision?